Math 1314 hypothesis test, population proportions, summary of testing proportions. All right, I know we have reviewed quite a bit, but I want to remind you of two things. Number one, it is a review. In theory, you should have seen most, if not all, of what you saw previously. And number two, there are two different approaches that have some similarities but also some differences. Behind me, you see a summary of those approaches that both start with the same first step, state the hypotheses, use the alternative hypothesis to determine left tail, right tail, or two tail. Now, depending upon whether you choose the p-value approach or critical value approach, or rather I should say, depending upon whether I ask you to do the p-value approach or the critical value approach, you would follow a different set of steps sort of from that point forward. If you're doing a critical value approach, your next move is to sketch the regions. This is the draw the picture move. And whether you cut off the left tail, the right tail, or both depends upon the alternative hypothesis. And remember that the middle is always the non-rejection region, and any tail or tails are the rejection region. If it's only one tail, then the other tail is part of the non-rejection region. Use the z-chart to find the critical values, because those are the z-scores that separate the regions. And remember that the significance level is the total area of the tail or tails. Your third step is to calculate the test statistic. If you're testing p, then your test statistic is z equals p hat minus p naught over the standard error, where the standard error is the square root of p naught times 1 minus p naught over n. Remember, p naught simply means the value of p from the null hypothesis. That's the zero subscript. But if you're testing the difference in two population proportions, p1 minus p2, then your test statistic formula is p hat 1 minus p hat 2 over the standard error, where the standard error is a larger formula. It's really this formula twice over with a plus in between, different sample sizes on the bottom, and all the p's become p bars, the pooled sample proportion. Then you make a decision based on which region, the non-rejection region or the rejection region, that the test statistic lands in. And remember, your decision is always about the null. You reject the null or do not reject the null. If you take the p-value approach, then after stating your hypotheses, your next move is to calculate the test statistic. So basically, you skip this step and go straight to step 3 using the same formulas. But over here, that's step 2. Step 3 is to calculate the p-value, which is the area of the tail cut off by the test statistic, double if two-tail test. So let's say it was a right tail test. Then I would take whatever z I get here, I would cut off this tail, and then I would use my z-chart to find this area, and that would be my p-value. The only difference is if it's two tails, you double that answer that you look up. And then you make a decision based on whether your p-value is less than the significance level or greater than or equal to. Just remember, small p-value means reject the null hypothesis. Small p-value means the probability of what we saw was so low that the null hypothesis is probably wrong. And of course, on both of them, you would answer the question in context if there were a context in which to answer the question. I know it seems like a lot, but we are going to review two more types of hypothesis testing before moving on to the next chapter. That would be testing one population mean and the difference in two population means. The good news is the flows are the same. The difference is the formulas, and we're going to be using the t-chart in those.